In this video, we're going to complete the KutaSoftware Infinite Algebra 2 free worksheet basic matrix operations. And for those basic operations, we're either going to be adding two matrices together, subtracting one matrix from another matrix, or we're going to be multiplying a matrix by a scalar. Now, our directions say to simplify, write undefined for expressions that are undefined. And an undefined expression, in order to add or subtract matrices, we need to have the same number of rows by the same number of columns. So, in the case of number 1, we have 1, 2, 3 rows and 1, 2 columns. So, this is a 3 by 2 matrix. Now, in order to add it to another matrix, that matrix also must be 3 by 2. So, 1, 2, 3 by 1, 2. Yes, it is. So because they're each a 3 by 2 matrix, we can add them. If they weren't, let's say that this second matrix had, let's put another 2 and 0 in here, expanding this matrix. That would be, as opposed to 3 rows by 2 columns, that would be 4 rows by 2 columns. And there's no way to add a 3 by 2 to a 4 by 2 matrix. Therefore, our answer in that case would be undefined. Same rules apply with subtraction. Each matrix has to be the same size. So there must be the same number of rows and the same number of columns for each matrix. So with that being said, we know that we can do number 1 because they're both 3 by 2s. So let's go ahead and complete this. Now, in order to simplify, when we add a 3 by 2 to another 3 by 2, that's going to be a 3 by 2 matrix. And when adding, we'll take the first row, first column, and add that with the first row, first column of our other matrix. So we'll have 3 plus 0 in the first row, first column of our final matrix. And then now I'm going to take 6 plus negative 1, or 6 minus 1, because 6 plus a negative 1 is the same as 6 minus 1. So first row, second column, first row, second column, first row, second column. So then, going down to my second row, first column, and I'll go ahead and label these rows one more time so that you can see. Row 1, 2, 3 by column 1, 2, and row 1, 2, 3 by column 1, 2. So because I'm dealing with row 2, column 1, I'll add that to row 2, column 1, and that will fill the spot row 2, column 1 in my matrix. So I'll have negative 1 plus 6. Now row 2, column 2 will get added to row 2, column 2 in row 2, column 2 of my answer. So negative 3 plus 0. Finally, row 3, column 1 plus row 3, column 1 is going to be negative 5 plus 2. Row 3, column 1 in my final matrix, and then row 3, column 2 plus row 3, column 2 will be row 3, column 2. Negative 1 plus 3. So now I just simply add and simplify. So my final matrix is going to be, well, 3 plus 0 is 3, 6 minus 1 is 5, negative 1 plus 6 is 5, negative 3 plus 0 is negative 3, negative 5 plus 2 is negative 3, and negative 1 plus 3 is a positive 2. So my matrix, reading by rows, 3, 5, 5, negative 3, negative 3, 2, or reading by columns, 3, 5, negative 3, 5, negative 3, 2. That's my solution in number 1. Let's move on to number 2. In number 2, now we're going to be subtracting. So let's see if we can subtract. We have a 1, 2 by 1, 2, 3. So this is a 2 by 3 matrix, and we're going to be subtracting a 1, 2, 1, 2, 3, another 2 by 3 matrix. So we can indeed subtract. And our result is going to be that same size, 2 by 3. So we're going to take row 1, column 1, subtract row 1, column 1 of our other matrix. So it'll be negative 5 minus 6, and then row 1, column 2, minus row 1, column 2 is going to be 2 minus a negative 5, which is 2 plus 5. And then row 1, column 3, row 1, column 3, subtracting those, negative 2 minus a negative 6 will be negative 2 plus 6. Now moving on to row 2, we'll do row 2, column 1, which is 4, minus row 2, column 1, which is 1. 4 minus 1, and then row 2, column 2, minus row 2, column 2, negative 2 minus 3, and then lastly, row 2, column 3, minus row 2, column 3, 0 minus negative 3, which is 0 plus 3. Now I'll rewrite this matrix, doing out the math. Negative 5 minus 6 is negative 11, 2 plus 5 is 7, negative 2 plus 6 is a positive 4, 4 minus 1 is 3, negative 2 minus 3 is negative 5, and 0 plus 3 is 3. So reading by row, negative 11, 7, 4, then 3, negative 5, 3, or reading by column, negative 11, 3, 7, negative 5, 4, 3. That's my solution in number 2. Now moving on to number 3, we're mixing things up a bit, and that's because now we're going to be multiplying by a scalar. And multiplying by a scalar is multiplying by just a number. So we're scaling this matrix by negative 5. So essentially we're going to be multiplying every single element in our matrix by negative 5. That's scaling the matrix by negative 5. So this will be, our result is still, let's count the rows, 1, 2 rows by 1, 2, 3 columns. So this is a 2 by 3 matrix, and the answer will also be a 2 by 3 matrix. So we'll have negative 5 times 5 for the first row, first column, and then negative 5 times 6 for the first row, second column, and then negative 5 times negative 4 for the first row, third column. And that all gets multiplied by, now I'm going to take this negative 5 and multiply it by each of my terms in my bottom row, or in my second row. So that'll be negative 5 times 4, negative 5 times negative 2, and then negative 5 times negative 1. So see how nicely everything lines up. Row 1 stays as row 1. It just gets multiplied by negative 5 each of those elements. Row 2 stays as row 2. It just gets multiplied by negative 5 as well. So now let's write this matrix out doing the math. Negative 5 times 5 is negative 25. Negative 5 times 6 is negative 30. Negative 5 times negative 4 is a positive 20. Then I have negative 5 times 4, which is negative 20. Negative 5 times negative 2 is a positive 10. And then negative 5 times negative 1 is a positive 5. So, reading by row, negative 25, negative 30, 20. Then negative 20, 10, 5. That's our matrix in number 3. In number 4, we're scaling again. This time we're scaling a 1, 2 by 2. So we're scaling a 2 by 2 matrix, so our result is going to be a 2 by 2. We're just going to multiply each of the elements by negative 5. So we'll have negative 5 times negative 3, negative 5 times 0, negative 5 times 0, and negative 5 times 5. So here you can see negative 3, 0. Each of those is multiplied by negative 5. And then 0, 5, each of those is multiplied by negative 5. So now doing out the math, negative 5 times negative 3 is going to be a positive 15, negative 5 times 0 is 0, negative 5 times 0 is 0, negative 5 times 5 is negative 25. So reading by row, 15, 0, 0, negative 25, or reading by column, 15, 0, 0, negative 25. That's my solution in number 4. In number 5, I'm back to adding. And remember, in order to add, I need to have the same number of rows, which in the first matrix I have 1 row, and in the second matrix I have 1 row. So the rows match. Now the columns must also match. So I have 1, 2 columns, 1, 2 columns. I have a 1 by 2 matrix, and I'm adding that to a 1 by 2 matrix. So because the rows and the columns are equivalent, I can go ahead and add those together, and my result is going to be a 1 by 2 matrix. So let's go ahead and add. I'll do row 1, column 1 with row 1, column 1, adding those, 4 plus a negative 2, and then row 1, column 2 plus row 1, column 2, 2 plus a negative 6. Now doing out the math, 4 plus negative 2 is positive 2, 2 plus negative 6 or 2 minus 6 is going to be negative 4. So 2, negative 4 is my matrix in number 5. In number 6, I'm going to be scaling a matrix. Let's talk about the size of that matrix. That matrix is a 2 by 1. So 2 rows by 1 column, 2 by 1. My result is going to be a 2 by 1 because I'm just scaling it. So my 5 will get multiplied to my 4 and my 3. So I have 5 times 4, and then I have 5 times 3 in matrix form. So 5 times 4 is 20, 5 times 3 is 15. This is 20, 15 as my solution in number 6. Let's move on to number 7. In number 7, I'm scaling my matrix negative 5 times, in my matrix I only have 1 row and 1, 2, 3, 4 columns, so this is a 1 by 4. My result when I multiply by a number, scaling it, will just be the same size, so I'll still have a 1 by 4. Except, in this case, each of my elements is multiplied by negative 5. So, first row, because there's only 1 row, first column is going to be 1 times negative 5. Second column is going to be negative 2 times negative 5. Third column is going to be negative 1 times negative 5. And then fourth column is going to be 2 times negative 5. So when I write this out, my 1 by 4 is negative 5, positive 10. Negative 1 times negative 5 is a positive 5. And then 2 times negative 5 is a negative 10. So my solution is negative 5, 10, 5, negative 10. In number 8, I'm scaling again. I'm just multiplying by a number. And my matrix is going to remain that same size. Over the course of this worksheet, none of my matrices change size. That happens when we multiply a matrix by another matrix. But we're not multiplying 2 matrices in this worksheet. We're either adding 2 matrices, subtracting 2 matrices, or we're multiplying a matrix by a scalar. And a scalar is just a number or some expression. So because we're just multiplying by 5, and this is a 3 by 2, it will remain a 3 by 2. So what I'm going to do is multiply every element by 5. So I'll have 5 times 5, and then 5 times 1 in my first row, 5 times 1 and 5 times negative 2 in my second row, 5 times 1 and 5 times 2 in my third row. So that's going to result in, well, my 3 by 2 is going to be 5 times 5, which is 25, 5 times 1, which is 5, 5 times 1, which is 5, 5 times negative 2, which is negative 10, 5 times 1, which is 5, and then 5 times 2, which is 10. So reading by row, that's 25, 5, 5, negative 10, 5, negative 10, or reading by column, 25, 5, 5, 5, negative 10, 10. Now moving on to number 9, they mix things up a bit because now we have some variables, but we're still doing the same thing. In this case, we're scaling a matrix, and the matrix that we're scaling is a 1 row by 4 column matrix, so our answer is also going to be a 1 by 4. We're just going to take this negative 2u and multiply it by every element. So we'll have negative 2u times 7u. That's going to be the first row, our only row, first column. And then we'll have negative 2u times 3w squared for our first row, second column. And then negative 2u times 5u for our first row, third column. And then lastly, first row, fourth column, that's going to be negative 2u times 5. Here's the negative 2u multiplied by 5. Now, let's do out the math. Negative 2 times 7 is a negative 14, and u times u is u squared. Negative 2u times 3w squared, negative 2 times 3 is negative 6, and that's uw squared. Or you could write this as negative 6w squared u. Either way is the same. Negative 2u times 5u is going to be negative 10u squared, and then negative 2u times 5 is just a negative 10u. So, reading the row, negative 14u squared, negative 6uw squared, negative 10u squared, and negative 10u. Moving on to number 10, we're going to be adding. And let's double check that we can add, making sure it's not undefined as our answer. We have a 2 by 1 added to a 2 by 1. So 2 rows by 1 column will be our result. So we'll simply add the same row and column together. So row 1, column 1 is 2, plus row 1, column 2 of the other matrix, which is 5. Row 2, column 1 of 4, plus row 2, column 1, which is 6. Here we have our 2 by 1 matrix still. 2 plus 5 is 7, 4 plus 6 is 10, so this matrix, our solution, is 7, 10. 2 rows, 1 column, 7, 10. Moving on to number 11, we're going to be scaling a matrix. And remember, the size of our matrix doesn't change for these basic operations that we're going over in this worksheet. So because my matrix size is a 3 by 1, my result will also be a 3 by 1. So what I'm going to do is just take the 4 and multiply by each of my elements. So I'll have 4 times negative 4, and then I'll have 4 times 3, and then I'll have 4 times negative 5. That will give me a 3 by 1. I'll just do out the math now. 4 times negative 4 is negative 16. 4 times 3 is 12. 4 times negative 5 is negative 20. And that's my solution. Negative 16, 12, negative 20. 3 rows, 1 column. Now on to number 12. In number 12, I'm adding my matrices, but let's double check to make sure I add them. The first matrix has 2 rows. The second matrix also has 2 rows. The first matrix has 2 columns, and the second matrix has 2 columns. So because both are 2 by 2 matrices, I can add them together, and my result will also be a 2 by 2. So let's go ahead and add these together. First row, first column by first row, first column, negative 4n plus 4, and then first row, second column, n plus m, added to first row, second column, negative 5, that would be n plus m minus 5, because adding a negative is the same as subtracting a positive. So that takes care of my first row in my answer. Now I just need to look at the bottom row. So I have negative 2n plus 3m, second row, first columns added together, negative 2n plus 3m, and then adding the second row, second columns together, that's negative 4n plus 0, which is just a negative 4n. And that's my solution because there's no way to simplify this down. negative 4n plus 4, n plus m minus 5 as my first row, and then negative 2n plus 3m, and then negative 4n. That was reading by rows. Reading by columns, negative 4n plus 4, negative 2n plus 3m, n plus m minus 5, negative 4n. Let's move on to the second page of this worksheet. And before we dive into our second page, if you're finding this video helpful so far, don't forget to give me a thumbs up. And if you feel so inclined, share this with somebody that you think will also find it helpful, and subscribe while you're at it. Now, let's do number 13. So in number 13, 2, negative 5, negative 3, the matrix, which is a 1 by 3, will get added to another 1 by 3. 1, negative 2, negative 3. So, row 1, column 1 will be 2 plus 1. And then, row 1, column 2 plus row 1, column 2, negative 5 plus a negative 2. And then lastly, negative 3 plus negative 3. Now, when I write this 1 by 3 matrix out, 2 plus 1 is 3, negative 5 plus negative 2 is negative 7, negative 3 plus negative 3 is negative 6. So 3, negative 7, negative 6 is my solution in number 13. In number 14, I have a 2 by 1 added to a 2 by 1, so I know I can add these together, and my result will be a 2 by 1. X plus y plus negative 5, adding the first row, first column together, x plus y plus negative 5, but as opposed to adding a negative, I'll subtract the positive. So x plus y minus 5 is my first row, and then in my second row, adding the second row, first column, and second row, first column, I'll get x minus 6 plus a negative 6xy, which is x minus 6 minus a positive 6xy. So x minus 6 minus 6xy is that second row. So this is a 2 by 1 matrix, where x plus y minus 5 is that first row, and x minus 6 minus 6xy is that second row. X plus y minus 5 is the only element in the first row, and x minus 6 minus 6xy is the only element in the second row. So a 2 by 1. Let's move on to number 15. In number 15, we're going to be scaling a 4 by 1 matrix, so that's going to result in a 4 by 1. So we'll have 4c times 0, then we'll have 4c times 6, then 4c times 0, and then lastly 4c times 3a. Multiplying this out, 4c times 0 is 0, 4c times 6 is 24c, 4c times 0 is 0, 4c times 3a is 12ca, or 12ac, however you wish to write it. So a 4 by 1 is my final solution in number 15. 0, 24c, 0, 12ca. In number 16, again, I'm scaling my matrix, multiplying by negative 3y. And this is a 2 by 2 matrix, so my result will also be 2 by 2. So multiplying negative 3y by the first row, first column, negative 2x, and then multiplying negative 3y by the first row, second column, negative y, and then negative 3y times the second row, first column, negative 4y, and then negative 3y times the second row, second column, negative 3x. So I have my 2 by 2, but let's simplify. Negative 3y times negative 2x is going to be 6yx, or 6xy, and then negative 3y times negative y is going to be positive 3y squared. Next, I'll do negative 3 times negative 4 times y, which results in a positive 12y squared. And then negative 3y times negative 3x is a positive 9y 9yx or 9xy. And that's my solution in number 16. Now on to number 17. I'm just multiplying everything by 3, which let's go ahead and just do this one out in our heads. So we know that we have a 3 by 1, so our result is going to be a 3 by 1. So we'll do 3 times 2u, which will be 6u, and then 3 times v squared, which is 3v squared, and then 3 times u, which is 3u. That's our solution in number 17. Here we have one row by 1, 2, 3 columns, because this negative x minus 1 is one element, negative 2x is the second element, and negative 5y is that third element. So a 1 by 3, we're subtracting another 1 by 3. So we can go ahead and just do this subtraction out. And let's go ahead and do it in our heads. So we have negative x minus 1 minus y. So that's negative x minus 1 minus y. Then for our first row, second column, we'll have negative 2x minus negative 2. So negative 2x minus a negative 2 is plus a positive 2. Minus a negative plus a positive. And then lastly, negative 5y minus a negative 3x will be the same as negative 5y plus a positive 3x. And that's my solution, a 1 by 3, negative x minus 1 minus y, negative 2x plus 2, and negative 5y plus 3x. Let's move on to number 19. In number 19, we're adding a 3 by 1 to another 3 by 1, which will result in a 3 by 1. So, adding the first row, first column together, we'll get negative 6r plus t plus, and I'll make this t a little bit darker so that you can see that it's a t and not a plus 6r. That's our first row, first column. Now we're going to do second row, so negative r plus a negative 4t. And then finally our third row, first column added to third row, first column is going to be 6x minus 3r plus 2, because we're adding a negative 3r, that's subtracting a positive 3r, and then we're adding 2. So if you notice in our very first row, we can simplify because negative 6r plus 6r is 0. So our resulting matrix, because that's the only thing I could simplify down, is going to be t negative r minus 4t, because adding a negative is the same as subtracting a positive, and then 6s minus 3r plus 2. That's my 3 by 1 solution in number 19. In number 20, I have a 4 by 1, and I'm adding that to a 4 by 1. So because I have a 4 by 1 added to a 4 by 1, my result is a 4 by 1. So writing this out, z minus 5 will get added to a negative 3y. And then we'll have negative 6 plus 3z and then negative 1 minus 6z plus 5 plus z, and then 3y plus 4z. Now we can simplify this matrix down a little bit more because we have some like terms. So in our first one, there's nothing to simplify, so we'll leave that first row, but as opposed to adding a negative, I'll subtract a positive 3y. In our second row, there's nothing to change either, so that will be negative 6 plus 3z. However, in our second row, we can combine -1 with 5. That's going to be a positive 4. And then -6z plus z minus 6z plus z, that's going to be -5z. So this -1 plus 5 is a positive 4 minus, because I'm subtracting 6z and adding 1z, that'll be -5z, so I'll write that as subtracting 5z. So 4 minus 5z, and then my last row I won't change either. That will still remain a 3y plus 4z because there are no like terms. And that's my final solution in number 20. Z minus 5 minus 3y is my first row, -6 plus 3z is my second row, 4 minus 5z is my third row, and 3y plus 4z is my last row, row number 4. Now on to number 21. In number 21, I'm doing two different operations. I have to scale my matrix and I'm going to subtract. So this matrix is multiplied by 5 and then I subtract. Order of operations still applies here, so I'm going to multiply first and then I'll subtract. So I'll have 5 times 6, 5 times 1, 5 times 2, and 5 times -6. That matrix I will compute and then I'll subtract 1, 6, -6, 6 from it. So 5 times 6 is 30, 5 times 1 is 5, 5 times 2 is 10, 5 times -6 is -30. So this is a 1 by 4 and I'll subtract 1, 6, -6, 6, which is also a 1 by 4. So doing the rest in my head, I'll do 30 minus 1, first row, first column, minus first row, first column, which will be 29. And then first row, second column, minus first row, second column, 5 minus 6 is a -1. Then 10 minus a -6 will be 10 plus 6, which is a positive 16. And that was first row, third column, first row, third column. And then first row, fourth column, or last column, first row, last column, -30 minus 6 is going to be a -36. So my solution in number 21 is a 1 by 4, 29, -1, 16, -36. Now in number 5, remember I said order of operations still applies. And you can see there's parentheses around these matrices that I'm going to be adding. So I'll add first and then scale. So I'll have -5 times 0 plus 2 is 2, -2 plus 0 is -2, and 5 plus 2 is 7. Now I'll go ahead and multiply. -5 times 2 is -10, -5 times -2 is a positive 10, and -5 times 7 is a -35. -10, 10, -35 is my 1 by 3 matrix in number 22. I had a 1 by 3 added to another 1 by 3, and then I scaled that sum by -5. Now in number 23, I'm subtracting my matrices. And again, order of operations still applies, and we're subtracting, so we're going to work left to right. So I'll start by subtracting this 2 by 2 by this other 2 by 2, and then I'll finally, after I subtract those, subtract the last 2 by 2 matrix. And because they're all the same size, I can do this. So I have 5 minus a -6, that'll be 5 plus a positive 6, because subtracting a negative is the same as adding a positive, which will be 11. And then I'll have 3 minus 0, which is 3. Then 5 minus 1, which is 4. And then 1 minus -4, which is 1 plus 4, which results in 5. So my matrix after subtracting the first two is 11, 3, 4, 5, reading by rows, or 11, 4, 3, 5, reading by columns. And then I'll subtract 5, 4, -2, -6. So 11 minus 5 is going to be 6. 3 minus 4, that's going to be a -1. 4 minus -2 is 4 plus 2, which results in 6. And then 5 minus a -6, 5 plus 6 is 11. So reading my solution by rows, I have 6, -1, 6, 11. Or reading it by columns, I have 6, 6, -1, 11. Now, on to the last problem in this worksheet, number 24. And in number 24, remember, order of operations still applies, so we're going to have to scale this matrix first by multiplying that all by 5. So I'll just rewrite this matrix, leaving it the same. 1, 1, 6, -4, 0, 0. Or 1, 6, 0, 1, -4, 0. And I'll add that to, let's do this math in our head. 5 times -4 is a -20. 5 times 6 is 30. 5 times 1 is 5. 5 times 1 is 5. 5 times -4 is a -20. And then 5 times -1 is a -5. Now I'll just add these. So 1 plus -20. That's going to result in a -19. And then I'll do 1 plus 30. That's going to be 31. And then 6 plus 5. That's going to be a positive 11. -4 plus 5. That's going to be a positive 1. 0 plus -20. That's going to be -20. And then 0 plus -5. That's going to be -5. So for my final solution on this worksheet, I have a 3 by 2 matrix because I added 2 separate 3 by 2 matrices together to get reading by row, -19, 31, 11, 1, -20, -5, or reading by column, -19, 11, -20, and then 31, 1, -5. Now on this worksheet, we were lucky enough to be able to add or subtract or scale everything. Nothing we had was undefined. But again, if there was something that was undefined, it would have been if we were trying to add or subtract matrices that were not the same size. The number of rows has to match the number of rows, and the number of columns has to match the number of columns in order to add or subtract matrices. This is very important. Otherwise, we cannot add. Scaling, it doesn't matter the size, we can always scale because we can always take that single digit or that single expression and multiply it in. The fun part is when we get into multiplying one matrix by another matrix. And I'll go over that in the next video. So stay tuned and check it out. Subscribe to my channel so that you know when I'll post that video. Also, don't forget to like and share. If you want more ways to support me, become a patron. Click the Patreon link to find out more information. Happy learning! See you next time.